I just keep it. Got it? Keep it. Alright guys. We're moving on. Moving on. I got the answer key, so you'll be able to check that out. What's up? Oh, okay. I'm going to give you the answer key anyway, but I know you can do this one. It's just a little long. You with me? I got the answer key too, so you can kind of check it out. Is it cool?
Let me put my head back.
What's up?
Let me put my head back.
Oh, yeah. Alright guys, we desperately try to get your attention back. Stop working on that. Yay. I'll give you the answer key in a bit. I just don't want to give you the answer key yet because I got the answers for the back stuff too, and I want you to work on that also. Oh shit, there's a whole other side of that thing. What? Alright. So guys, help me out. How would I graph x equals 2? How would I graph just x equals 2? I just need a number line.
I mean, yeah, it's a right. It's a right.
What's happening? X equals 2. How would I plot?
2.
There was problems like this in the homework throughout the semester. Alright. So I got like -1, 0, 1, 2, 3. I would just put a point there. It's amazing, right? That is amazing. What we want to do is we want to give ourselves more room to move. This is what's called one-dimensional plotting. I can only move left and right. That's it. So I want to add in a second dimension to this. Right? I want to be able to move up and down also. Now if I move in a second dimension, I have to be able to tell somebody not only how far to move left or right, but also how far to move up and down. And the math geniuses that we are, we said, well, this is x. Let's call the other one y. And well, this one's going this way. We'll make the other one go that way. So we've got this kind of thing going on. Right? The classic example is latitude and longitude. You look at a map and you can tell where a boat is by telling the latitude, longitude. That's just finding the x and the y on the surface of the globe. You guys semi with me? If you're into astronomy, you have the same kind of thing for finding stars. Right ascension and declination and weird shit like that. It's just x and y. It's just weird names for x and y.
Wow.
Because. So what we do, what we always assume, is that a point that's given to me is in alphabetical order. It goes x, comma, y. So if I want to say what that point is right there, I want to tell somebody how far they have to move left or right, and how far they have to move up or down. Yeah, so for that point right there, the x is 1, so go over 1, up 2. Now that point that I keep starting at, that's called, not surprisingly, this point right there is called the origin, because that's where I originate. That's where I start when I go to find a point. And of course, if I start there, I haven't moved yet at all, so what's the point for that origin? What's the point going to be? This is 1, 2, what's this? 0, 0. I love it, because I haven't gone anywhere yet. So it's the point 0, 0. So what point is this one right there?
1, -2.
Careful. Yeah, -2, 1. Order matters. The first number tells somebody how far to move left or right, and the second number tells somebody how to move up and down. Have you ever been to Salt Lake City? Their streets are perfect grids. It kind of is creepy in a way. So you gotta go, wow, 2 blocks back and 1 block up, and then you get there. You go. That's how to tell somebody how to move around in a city that's perfectly laid out in a grid. I like it. Virginia Beach, where I used to be, they had roads that intersected with themselves, so it didn't quite work that way. But oh well. little fish there. I like it. So what point is this going to be?
0.
Beautiful. Don't move at all left and right. Only go up 3. So don't move left or right at all. Only go up 3. Oh, that kicks a lot of ass. And of course, what point is this? Yeah, only go back. Only go back 2. Don't go up and down at all.
Tired.
Yes, ma'am.
Sorry, I'm having a brain fart. Okay, so when you're listing there, or like, I'm trying to do number 1 on here. Do you put the X first or the Y first in your like formations, like when you're trying to write? X, Y. Okay.
Yeah. Are you guys? What are you guys doing right now? Are you guys doing that side of the thing? Is that what you guys are doing?
I'm trying.
Or are you guys trying to finish the other side?
I'm trying to finish
Yes. Not true. Not everybody.
The
Yeah.
numbers have to be in order, right?
Say again? Yes, they have to be in order. So the point 1, 2 can only mean this point. It can't also mean the point 1, 2 like that. No. This point would be what? 2, 1.
Okay.
Those are different points. I like it. So order matters. Totally. Now let me just say right now, this doesn't have to always be the x-axis. If I'm talking about, I'm throwing a ball, and this is the height, and this is the time after I threw it. So I throw a ball, so then every point would be where the ball is at that time. Do you guys see what I'm saying? So then a point would be T, comma, H. So it doesn't even have to, but when it's X and Y, we know it's got to be X, comma, Y. Don't freak out about the whole T and H thing I just showed you. I just want to show you that we can call these axes something that makes more sense for the problem. If this is time and that's height, I'm going to call it T and H. It makes more sense. We're not going to do that here. We're just going to leave it X and Y. I like it. So if I wanted to plot the point -4, -2, yeah, so tell me how to go from here. 4 back,
And 2 down.
down 2, I like it. So right there, that would be the point, -4, -2. Kick ass. I like it.
What was that?
The point -4, -2.
I know, but it's going to go loud.
-4, -2. I like it. Makes a lot more sense when you pay attention to the whole thing. Now, what gets really kind of nifty is when I get points from a place like an equation, that very often the points will make a certain type of shape. So for example, the thing about throwing the ball that I just talked about, I don't know if anybody knows the name of that, that's called a parabola. And that comes from an equation like y = x squared or something. That would be a curve. Right? We're going to talk about just straight lines. So let me ask you this. If I have this equation here, sure, I like it. Now, here's one big reason why we graph things. If I ask you, what are all the answers to this? Does anybody have any idea how many answers this thing has?
A lot.
Yeah, a whole hell of it. There's an infinite number of answers. So the way I can do this, so if somebody says, what's all the answers to this? I'm not going to list them all. Screw that. I'm going to draw the picture and say, you go find whatever answer you want. I'm done with that. So somebody help me out. Give me some answers for this. If x is...
3, 4, 5.
No. An answer to this equation requires how many parts to it?
3.
2. Because how many things are there in this equation that I don't know? 2. So x has to be something and y has to be something. That would be one answer. So I'll tell you what. Let's do this second. Let's do this one first. This one's a little easier to think about. X plus y = 4. Give me some answers. 2 and 2. That's one answer, right? Give me another answer. 3 and 1. 1 and 3.
4 and 0.
4 and 0. 0 and 4. 100 and negative 96. Yes, what's 100 plus negative 96? 4. Now why did I do that weird shit? Because number 1, I'm a weird math teacher. Number 2, to really make sure you understand, there's an infinite number of answers here. What about 3.11 and 0.89? Yeah? Would I ever come up with that for myself? Hell no. I don't want to do that. Why do we not want to do that? Because I don't want to graph that point. That point is going to be really sucky to try to graph. I want to make nice numbers that I can graph, and then when I fill it in, every point that line goes through will be an answer. It's going to catch the weird shit like 3.11, comma, 0.89. I'm not going to have to get it myself. That's why we make a graph with points and then we fill it in. Because as I fill it in, I capture all the other answers. Does that make sense? When I graph an equation, I'm giving a visualization of all the answers to that equation. All the freaky ass answers included. Right? So if I plot this, how do I graph this now? Well, I just got a bunch of points to graph. I'm not going to graph the 96 one. So 2, 2. How would I plot that?
2, 2. Right.
That's awesome.
2, go up, 2.
I like it. There we go. That's what I want to hear. There's 2, 2. 3, 1.
4, 3, 1.
You'll get it? Let's call this A, B, C, D, E. That's A, B. 1, 3.
Go right 1.
Right 1.
And then
Up 3.
It's like Battlefield.
You sank my battleship.
Go over 4.
Good. Over 4.
And then just
Stay
down
there.
that line.
Do you see the pattern it's making? If the points you're plotting come from an equation, there will be a pattern to them.
Yeah.
It makes sense. There's a relationship between these two. Together they make 4. So the visualization of them should have some kind of a pattern. If I start putting squares and cubes and weird shit, I'm going to get pattern. If I start doing trig, or I'm going to get the. And if I do really weird shit, I can get spirograph pictures. Believe it or not, there's an equation for what I'm doing right now in the air. There's an equation that does this. There is. It's crazy. You're like, whatever, Jeff. You're the weirdo with the aliens earlier.
Okay.
Where am I at? There's D, and then E is 0, 4. So 0, 4. So there's the nice line. So whatever point that is right here. Now, I want you to realize, whatever point that is right there, whatever freaky ass point that is, can somebody tell me what must be true about it?
The 4?
When I add the parts together, it's got to make 4. And that's, like I said, that could be like the 1.2 comma 2.8. Because 1.2 plus 2.8 is 4. So when you fill in between the points, you pick up all the freaky decimal and radical and all the other weird-ass answers. And that's why you make nice answers for yourself. Because you're going to get all the other ones when you fill it in. How's that? I mean, I don't know why people won't tell you this. That's what graphing is all about. So that's the first and primary reason why we do it. So what about this one? This one's a little bit different, but I can let x be something, like let x be 0. Then what's y going to be if I make x 0? 2 times 0. Plus 1, you guys see that? Where did I get 0 from?
Right there.
It wasn't there a second ago. Where did I get it from? Because what can x be? Anything. So I'm going to pick nice things. I'm not going to pick 99.7, although it could be 99.7. I'm not going to let it be 99.7. I'm going to say let x be 0, and then what must y be for that then? Y equals, what's 2 times 0? 0. Y equals 1. I love that when people multiply by 0 and it doesn't become 0, so be careful about that.
Oh, so you want it the next?
No, that's going to be 0. When you multiply by 0, it's 0. What else can I let x be? Somebody else give me another number.
8.
2? Okay.
I said 8.
So what? So I get y equals 2 times 2. I'm letting x be 2. So everybody see what's happening. You can choose anything you want to for x, or really for y if you wanted to. Normally we think of x as the input.
How did you get the one there?
Here's the equation. That's the relationship between x and y. So if x is 2, what's y? It's twice that plus 1. What is y always? Twice x plus 1. So you get 5. I like it.
And there's a pattern. You just plug it in.
What about negative 1? Y equals 2 times negative 1 plus 1? What's 2 times negative 1? Negative 2. Plus 1, what's y? What's negative 2 plus 1? Negative 1. So then you can plot the point 0, 1, 2, 5, negative 1, negative 1, and it would make a nice line. Believe it or not. Alright? So wherever the points come from, you can plot them, but you only connect them. Don't connect these when I just give you points from out of nowhere. If your points come from an equation, then you want to connect them. Because then the middle parts mean something. They are also answers to the equation. I like it. So if I plot this equation, this one here, of course I go to 5.
Shoot.
So 0, 1, that's a 1, that y just got crazy. 0, 1, where's that?
Right.
Careful now. 0,
Right there.
1. So there's 0, 1.
Yeah, but then we go to the right.
How much do I move left or right? Done. How much do I move left, up or down? 1. The first number tells me how much I move left or right. So if I went here, then I'm at 1. Does it say 1? No. It says 0. Alright, what else can I do? Rick, what point is this? 1? 1. What point is this? Negative 1, 1. So what point must this be right in the middle? 0, 1. Don't go anywhere from here, only go up 1. Alright, I like it. So if there's a 0 here, you only go up or down. If there's a 0 here, you only go left or right. Because what does x control? What kind of motion does x control? Left and right. Because that's the x-axis, right? And what kind of motion does y control? Up and down. So if x is 0, you don't go this way at all. You only go up or down. So here I only go up 1. Bam. So what about the point 2, 5? Where's that? Up 5, I like it. 1, 2, 3, 4, 5. There it is. So that's the second point. Well, what about negative 1, negative 1?
You go down, and then you go up.
Yeah. So over, down, or down, over? Sure? Down, yeah. Over 1, down, yeah. Either way. And now you make a nice line. I like the mathematical Bob Ross. There's a line there. The Bob Ross. No love for Bob Ross.
Are you kidding me? I love Bob Ross.
There you go, the
Look at these
reaction.
little trees. They're beautiful.
I know. Everybody loves.
Aw, beautiful. Look at this patch. I used to watch Bob
All
Ross
right.
every
So believe it or not,
Yeah.
I think you're ready. So you haven't already done this. Do the other side of that handout. Everybody with me? The other side of that solvent equations handout, there's a lot of graphing problems.
I need help.
Okay. So do the other
So I
side.
got this part.
Like
This part.
3
This part and this part.
Oh, so just don't use that one. You know what I mean? When you go to plot it, when you go to graph, just don't use that one. Sort of like I didn't use the 100. No. When you do this, you know what? When you graph this, isn't that going to keep going forever?
Yeah.
So isn't it going to go up to x and then negative up to 28 zillion or something?
Right.
Oh, wait. Oh, so that's a problem with this one probably. Where that goes.
So remember left.
So if x is 0. Can I say that looks good? So maybe there's a problem with one of the other ones.
Anything over here.
Let's see, when x is 2.
Right.
Y is 1. That looks good. Let's check this guy out. When y is 3, where's your work here?
Yeah, so for A.
Oh, that's a y
start
there.
on
I'm sorry.
So 1,
Yeah, you got it.
2,
Oh, right there.
4.
3 plus 3.
Then go over -4.
6.
Yeah.
And then you gotta go on.
But you see what I mean, Jackie? I mean, that point still works. If you go to -3,
You gotta go down.
it will go to -9. You see, it's headed that way.
You went,
But it's just off my graph.
and you went down.
Yeah, you're good.
And -1.
But this is what I'm talking about. So you go to -3, 1, 2, 3. Go down 9, but it's off your graph. So just don't plot. But see how that's going to go down there and catch it
Because it says
eventually?
here, it says
It's just off your
So do I
graph.
plot it or just leave
So,
it?
You don't plot the 3, -9.
-4.
Because when you put the little arrows on the ends, it just says keep going forever. You would eventually get there.
B, you
Yeah.
have to go back over and then
That's how it
it's
is.
1, 2, 3. But then you go up. So you're in the positives.
Create your own.
So it's, you have to go over -3. You go up 2. So it's -2 is equal to 2. Makes sense.
Yeah. Why?
But see all of this, and then you're in the negative points here.
Never.
And then here you're in the positive. So you have to go this way, so you get the negatives first, and then you have to go up, so you get the positive. So -3, 1, 2, 3. You had to go up 2, so 1, 2, 5. So this is how you would write it. This way.
That's what that white kid was like. We have to
Write
write
the
that.
X plane first, and then the Y plane. You always write this. You always write this first, and then this second. How many you have to travel?
Start from the original.
Yep. Yep. So C, if you're going in the positive field, C is over to your right. So you have to travel 1, 2, 3, 4, which is in the positives. So you write 4, comma, and then it's still on that X plane. It didn't move down or up, so it's 0. It's on the plane before. So if it's on this hard line, it's always going to be 0.
Solve for y. You know what y is? When x is 2.
So you have to go over 1 to the negative field. So -1.
You gotta rewrite this 2.
But then you have to go up into the positive. So 1, 2.
They told you that. For the second problem, I'm gonna put
Wait, there's both of them.
yeah, you know.
This is for this. It's asking you how to find this. Tell me where to find this.
So it's positive.
Yeah.
Yep.
Another way to look at
And then
it.
start on
4
this
minus
plane
0.
first. Nope. Because if it was 0, the E would be right here.
Oh,
So you have to go down into the negative plane. So you start here, you go 1, 2, and then you have to go down into the negative plane. See, does this help? Like, quite fine. So I'm saying, because you went down, get to your negative, go this way or down, your negative, and go up or right.
You could, but it's just that x is first and y is second.
I like this like just piss them off.
Because then that's a question of what you want to do.
And then over here, you get just like a positive energy. So it's going to be a positive, so it's going to be negative. You're on that side, positive, negative, positive.
You would die.
And then, see if you can point that way. Okay, so you always do the X plane first. So 0.
Well, no, yes, sir.
No, I do too. No, I do too.
Well, that's. Yeah. So that's the intersection with. That's 6. So that's -6, right?
Yes.
Okay, keep going. -6 minus y plus 3. Now solve that equation.
So you can't go anywhere because it's actually saying that it's at the origin.
Negative y.
So 0, that's 0, period. This is 0 regardless.
Negative y is 9.
And you can't go anywhere. And then the next number is positive. So it's positive to go up or down.
You can divide both sides by negative 1.
So how many can go up?
I want to know why. If I know that negative y is 9,
Up to, you're at 0
y must be
already.
negative 1.
So 1, 2, 0 is here. At 0.
Each one of these, you know one of them.
The next number is
Plug a value in and you solve for the other.
Because this is X. That's how you plot.
Oh, right. Yeah. What's another? They're a lot better.
These I remember. These I remember. I just don't remember this crap.
And then you get negative y.
I remember that's what the only thing I had to ask him was,
So you got
Mine always sits like on the
-3, so it's a negative. So how many? 3, and then that's a positive. So you go from this line, you're going to go 4, 5. So there it is.
like, oh, you're older. You know?
Dots.
Well, when I'm 31, it's
-2.
well, yeah, it's over that.
And then was that -3?
Probably.
Yeah. So if you go up, you're in the positive plane. So you go down. So down, it's 2. There you go. 3.
On the first. We don't have
And then, okay, so then
Does he want to kill that
here.
negative? So why? So why?
You're going to go to negative 4 spots over. And then since it's on the 0, it's not going to just stay there. So put the little dot there.
And they just do it like me. No, because like you guys just like to go something like that.
Yep.
Some guys like to feel it too.
Is it? Is that easier?
Like I said stuff like that to people a lot of times.
So yeah.
And then they still
Let's see. Oh, there's
They're not in order.
I got it. So you gotta be careful.
that's how come
Don't go up to the ball, right? Only go up.
some
Don't be out.
all of
Go
them.
over and then not go up and down.
I don't
Some of them that's just
Second number is
look at it and
y.
then my brain click.
Maybe 4 0.
So that's exactly correct.
Well, let's see.
So yeah, like I said, like I already draw here because this helps me, but I always draw X,
This one is negative 1, negative 2.
but doesn't that bump up?
A lot of shopping.
Go back one line and then go up.
It's
Yeah, it's negative.
it dummies it.
That's like
That's how
I would buy a lot of I would close, yeah. But I want to know how many I gotta go research. Now I have money. At least a little something.
All right, guys, real quick. This is driving me just a little crazy, but I mean, this is kind of new to you guys. But I want you to realize the minute you use this information, it is old news. It's stuff you should know. What do I know in this first point so far? What do I know about it?
But
x is 2. Alright, so x is 2 for this first problem. So I replace x with 2. And now I've got an equation that I can solve. Every single time, if they give me one letter, I've got a normal equation that I can solve for the other letter. Does that make sense? Because right now, how many letters do I not know in the beginning? 2. I got 2 things I don't know. So if you give me one of them, I can solve for the other one. That's why they make points. They have these numbers that go together that make this thing work. So here, it would be 4 minus y equals 3. Oh shit. Subtract.
Thank you.
Subtract 4. So you get negative y equals negative 1. How do I kill that negative? I just divide by negative 1, so your y is 1. So here you do the same thing, except where do you put the 3? Don't be too creative. I'll tell you where to put the 3, Jeff. No.
In the y spot.
In the y spot. And then you solve for x. It just becomes an equation that you can solve for the letter. That's why, this is another reason why solving an equation is so important, because it shows up in all these other things, like graphing. That's me talking to myself.
I know, don't you need to like hear yourself on the, like a voicemail? You're like, I sound like that?
Jeff, I
Oh,
have
yeah.
a question.
Yes.
So if you think it was 4x, it would have been 4, right?
Say again?
I think it was 4x.
4x?
Yeah. So what was that?
That would have been 4 times 2. It would have been 8. I don't know what you mean.
Would it be 4 with a 4? Or would it be